Okay, in this presentation we're going to look at a continuous distribution example, particularly an exponential random variable. Now, so claim amounts are modeled as an exponential random variable with mean 1,000 US dollars. Okay, so mu is equal to 1,000. Okay, and if the mu is 1,000, that means the rate parameter, lambda, is 1 over mu, which is equal to 1 over 1,000. Okay, now that's something we're going to need later on. Okay, so calculate the probability that one such claim amount is greater than 5,000 US dollars, and then calculate the probability that a claim amount is greater than 5,000 US dollars given that it is greater than $1,000. Okay, so let x be an exponential random variable with our rate parameter lambda equals to 1 over 1,000. And we have the probability density functions here, small f of x and capital F of x. That's the cumulative distribution function there. You should know both of those immediately, okay, and be able to derive them in some cases, okay. So those are the two things that we're going to use. Now I'm not really answering the question there, although actually this part you should put in. Just actually spell out explicitly what x is when you do this question, and also put in other things as well, like where x is greater than equal to 0. Put in stuff like that into your answer. Okay, that's the formalities of it. So oops, didn't mean to do that. So essentially what we're asked to do here is find the probability of x being greater than 5,000. Equivalently, because x is a continuous random variable, that is equivalent to that. The reason is that the probability that it takes exactly a certain value is considered to be negligible. Okay, so I keep getting asked that quite a lot. So the formula that we're going to use is this formula here, and this is essentially the reciprocal of the cumulative distribution function. The cumulative distribution function is a probability of x less than some particular value. Okay. Sorry, I actually used two different terms there, x and t, but it doesn't really matter. Okay, so I'm mixing up my notation. Anyway, probability of x greater than 5,000 equal to e to the minus lambda t, and we already know that lambda is equal to 1 over 1,000. Okay, so minus e to the minus 1 over 1,000 times 5,000. Essentially, we're dividing 5,000 by 1,000, so we get e to the minus 5, bit of calculator work, and we get 0.0067. Okay, that's the answer to the first question. Now, the second question is calculate the probability that the claim amount is greater than 5,000 US dollars, given that it is already greater than 1,000 US dollars. There's two different approaches I'm going to take here. Okay, both of them have good learning outcomes. I'll tell you what, I'll just actually look at the first one or the second one first, because it is the memoryless property of the exponential distribution, means that the probability of x being greater than 5,000, given that x is greater than 1,000, is essentially the difference of the two, which is e to the minus 4. Okay, now the memoryless property of the exponential distribution is something that you can usually invoke straight away without having to back it up. It's one of these things that, you know, it's a sort of characteristic of the exponential distribution, and the trick is just to see, do you know it? Okay, so that's the memoryless property. I'm not going to go into too much detail here because it requires a good bit of explanation, and this is really a tutorial video. Okay, now so with time 1 greater than time 2, or t1 greater than t2, actually totals, I usually use this for time, actually, that's why I'm using t. So the probability of x greater than t1, given the probability of x greater than t2, can be written as using the conditional probability formula, which is the probability of x greater than t1 and x greater than t2. Okay. Now, the idea here is that if x is greater than t1 and t2, it is essentially equivalent to the larger of those two numbers there. Okay? So if I'm, let's say, older than 20 and older than 30, I can say, really, just to cut a long story short, I'm older than 30 and so on. So essentially what we could do is re-express this as this, okay? And probability of x greater than t2. So it's essentially the probability of x greater than t1. Here that's 5,000. And t2 is 1,000. So, a little typo there. Essentially what we do there is just work out e to the lambda t for 1 and 2. Okay, so we have e to the minus 5, which we got before, and then e to the minus 1, which is 1,000 divided by 1,000 and minus that. So e to the minus 5 divided by e to the minus 1, that gives us e to the minus 4. Just actually, as good practice, always be ready for these exponential calculations. And all this sort of stuff there. Know that stuff inside out. Have it like a reflex. Be able to use the exponential numbers and stuff like that. Okay. Anyway, the answer works out to be 0.00182. Okay, so that's good. We'll leave it there.